Hello, this is the first of a series which I'm going to call the AA7FO Construction Experiments Series. This is number 1. Today's date is September 13th, 2025, and it's a Saturday. A few days ago I got my copy of Experimental Methods in RF Design, which I ordered from the ARRL. This is their new printing with typos and schematics corrected. Don't know if they got them all. Our job is to find them. This book is going to eat your lunch. It's going to eat mine. So we're going to do the best we can. It is packed with lots of goodies. Some you may be interested in and some you're not. So we get to pick and choose. The book is written by Wes Hayward, Rick Campbell, Bob Larkin. Wes and Rick are both members of the QRP Hall of Fame, and Bob Larkin should be in there because he's contributed a lot to the hobby, the technical end of it and everything. These guys have written a lot of stuff. This book costs $49.95. It's going to cost you $10 and some change for shipping, and then you're going to have to pay your state taxes. So mine came out $66 and something. So just figure the price of the book as an entrance into this course. I'll kind of treat it like a course. Excuse me. So what are we going to do? We're going to go through here and start at the first. Now, I won't be doing too much out of this book. I've got a old copy scanned in, and I'm going to have to use it because if you look here, trouble with LED lighting is you're going to get these bars that move across in sync with the video. So in chapter 1, we're talking about home brewing and the pursuit of new talks about different construction techniques. One of them is the ugly, which Wes and I guess all three authors are fans of. So we'll show a couple of things, but I won't be building that way. I'm going to build a circuit board. I did some Manhattan. Let me show you. Here's the ugly. And then they say, if you build it nice looking, and this is the way we used to do Heath kits back in the 50s and 60s and later when they had vacuum tubes, said nice looking circuit construction does not always equate to good circuit performance. Here's another ugly. And this is the direct conversion receiver, and we're going to build that, but not first. Let me show you. On QRP Tech, I had the guys ask them to build this audio amplifier. Manhattan style, and this is my result. This is, let's see, I have to look at this. It must go this way. This is a power supply, 9 volts or 12 volts. Input here, output here. And it looks pretty nice, except that it's kind of difficult to get newbies into the swing of things. So I'm not going to do that starting out here. I am going to use a thing called toner transfer, where we make a printed circuit board. If you look at this and compare them, and I didn't try to compress this, I can get it probably in half that area. But one of the things that building this way is going to allow me to do is to give you the layout, and you can use your printer to print it, etch the board, drill the holes, and build the thing for a lot of stuff. Again, pick and choose. So that's what I'm going to do. Here they did a looks like a PCB edge for surface mount, and we'll get into parts stuff later. Was there anything else in this chapter that I wanted to talk about? No, but we'll build a couple of things out here. So that's the plan. Now I'm going to have to do a web page, and I'm going to do it at www.qsl.net/aces.html for AA7FO Construction Experiments Series, and I will put pointers in there to corrections, things that I do wrong in the video, and links to where resources are. There's a lot of stuff to talk about. I've got to limit each discussion to 15 minutes because one, attention spans, two, you get overloaded, so we'll just do that. Now I did an experiment here. Let me show you where we're going. One of the things I've been doing, I built using the toner transfer a new frequency counter. Let me power it up here. Let me find my power supply. Use a little lithium-ion pack. This is a copy of the NorCal FCC1, and I've got it calibrated with the GPSDO, Global Positioning Satellite Discipline Oscillator. So this thing is good to 1 hertz. I redid the FCC1 because I wanted a backlight. And this is at half intensity, and this is at full. I will check the resulting video, see which one we prefer. But I've been doing experiments with oven control crystal oscillators, and this is one. You can get these off of AliExpress for about $7 a piece. And I have 7 of these from CTI. I'll come back to it later. Without doing any correction on the output to sync it to 10.0 exactly, out of the box, these things came out of decommissioned cell towers, etc. The worst case, the part was only 6 parts off of being exact. The best one was only 1 hertz off. Now these things, when you start them up, because of the oven, they'll start up at around 800 milliamps. Then after 3 or 4 minutes, when they get to temperature, the current will drop, and it's somewhere between 150 and 220 milliamps, and it'll fluctuate depending upon the environment. The temperature of the case gets to 30 degrees Celsius, which is warm. Now that runs off of 12 volts, and I've found out that it's got a 5-volt regulator, so I can run it down to almost 8 volts and it not change. Here's a small one made by IsoTemp, and I forget what the price of these may be a little bit lower, but it runs on 5 volts. And because it's running on 5 volts, it's going to draw a higher current. Okay, I think all these run around 1.5 and 2 watts. But the small one here, the temperature of the case goes to 48 degrees Celsius, which is pretty hot. Okay, but it's used in a lot of things, and eventually I'm going to work my way up to. This is just a test board that I did that had a filter on it, and I took it off. I'm going to come up with a board that has some oven-controlled crystal oscillator on it, a small $2 microprocessor system, and a GPS unit, something like you can get from QRP Labs for $25. I don't know what's going to happen because I just read an article. We're not the only hobby that's getting hit by the tariffs, because the stupid shipping companies like DHL, FedEx, UPS. If we buy something for some electronic parts for $5, well, the tariff on it's going to be whatever, $2, $3, whatever it is. The shipping company is going to charge you $15, $17, $23 for an administrative charge. This means that for every $1 million they collect for the U.S. government on tariffs, they're going to collect 10 million. So they're getting rich off this. We get screwed. So that's my political views. We just do what we can do. All right. So plan is, and I think I exceeded my 15 minutes. Sorry. I'm going to start with a simple project we'll get off the web and build it from start to finish using a printed circuit board technique. I hope I get your interest here. Do some likes and come back and we'll do some more fun stuff. Thank you.